From raw data to an emotional experience, I want to show you guys how I design interactive hardware as a product designer. Before we dive in, I want to give a special thanks to PCBWay for sponsoring this video. If you're looking to design electronic devices like this, and you want to prototype with a custom PCB, head over to PCBWay because they make it super easy for you to order your custom PCB in minutes. It's super easy to get started. All you really need to do is start by uploading your custom PCB file. And once it's uploaded, you get a preview of your custom PCB. You can then start customizing the thickness as well as picking the color of your custom PCB. They also offer PCB assembly, so your PCB could be ready to go once it arrives at your door. What's cool too is you can see the pricing as well as build time for your PCB. Once it's ready, just click Save to Cart and just simply upload your bill of materials and your order will be reviewed and ready for production. PCBWay has made it super easy for creators to prototype. So my project began with research into motion sensors that led me to the ADXL345. But as someone who's new to electronics, interpreting schematics and data sheets was a huge challenge for me. So this is where I use AI to help me understand these technical jargons and turn this information into actionable items, which guided me through the integration process that helped me set up and implement this sensor. AI-assisted learning has really made it possible for me to interface with this hardware and start coding in a new language. Now, this would have been something that is significantly more challenging without the AI guidance because I come from a web development and design background, and this is a totally new language for me. But once I could visualize the sensor data, watching the X, Y, and Z coordinates change with movement, the next challenge was really transforming these numerical values into meaningful interactions. So things like detecting activity, sudden acceleration, orientation, shaking, and as well as tap detection. So my design philosophy is to engage users with these meaningful interactions. By mapping the sensor's sensitivity along each of the axes and applying just basic trigonometry with the help of AI, I was able to identify several potential interaction patterns that could be calculated through the raw data. So basic movements such as just detecting shake when a user shakes the device, as well as detecting orientation change, right? What can you do with these type of data? You could do some pretty fun stuff. Aside from motion, what got me thinking was, what can I do as well with detecting inactivity? And I will get into this in a bit, but what made all of these calculations possible was this basic math function where I take in the raw data within the axes, and then you calculate the magnitude. I use AI to help me formulate this formula that detects and calculates the combined magnitude of movements. Now, if you have just a looping animation, this is a demo here. It's not really engaging, right? It's pretty simple to do. So the real design challenge was elevating these physical inputs into features that would stir emotions to the user. So in UX, we call this micro interactions. It's basically taking your functional logic and turning them into emotional output. Let's take activity and inactivity detection, for example. So functionally, you could conserve battery life by triggering deep sleep during periods of inactivity, right? But how could this become an emotional experience for the user? So I approached this design challenge by breaking things down into meaningful sequence. I started by setting these timers. So, you start a countdown timer for 1.5 hours of inactivity, which would then trigger deep sleep. Now, the second timer I set is for 30 minutes, and this would effectively start dimming the display, but it also tells me when he's about to become idle. Now, the last timer I set is for 1 hour and 20 minutes. And this one is where I used to play a sequence of sleeping animations. So I'm going to show you the function that I wrote for this. This function here called auto dim display. So this function will handle all the timers that I've showed you earlier. So what it starts to do is, as I mentioned, it will start to detect and dim the display once there's inactivity that's been detected, and the timer starts kicking in. Now, once it kicks in, it will also transition into a sleeping state, where this gives me the opportunity to play a sleeping animation until there's interruption that resets the timer. So I want to show you the function that actually handles the animation sequence. I have this function here, and what it does is that it actually has a state management that breaks it down into 3 separate states. So the 3 states are entering sleep, sleeping, and exiting sleep. The first state is basically detected within that timer I mentioned. So when an hour and 20 minutes kicks in, he will start feeling sleepy, and this will give me the opportunity to play like a sleepy animation, right? So once this animation is played, he will then enter into the second state, where it just loops a sleeping animation. And this animation will continue to loop until motion is detected. And that's when he will break from that animation and play a wake up or like startle animation. So with this chain of animation, it creates a human-like behavior that creates an emotional connection that we recognize and relate to, right? So I designed it logic from just raw values to translate them into a delightful experience. So apart from this design challenge, the hardware also imposed some constraints that wasn't apparent and only surfaced through during my exploration. And what I discovered was that during deep sleep, the device just shuts down. I cannot play any animations at all. So understanding this limitation really helped me design around it rather than kind of fight against it, which is why I introduced the timer logic to create that intentional micro interactions for inactivity before he goes into deep sleep. Now, I just want to say that AI has really transformed what was once required years of technical experience, really helped me to design and implement these ideas. So with each sensor input from the accelerometer, it became an opportunity to design micro interactions that transforms the raw data into an emotional and engaging experience. It's all about seeing the creative opportunity within data. I hope you guys enjoyed this video. Thanks for watching, and thanks for your support with Byte 90.